Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and I'll now turn it over to our speaker for introductions.
Awesome. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening. Welcome wherever you are in the world. Welcome to today's episode of IoT for Beginners, where we're focusing on digital agriculture. Now, going to open with a couple of apologies. I was off sick yesterday, and I have not been sleeping well. So if I'm yawning at any time during this session, I do apologize. I'm absolutely exhausted at the moment. And second apology is, it seems Thursday morning is the day that here in suburban America, the gardeners like to come round. So it's a bit quieter than it was about 10 minutes ago, but there's a whole lot of gardeners with petrol-powered leaf blowers, lawn mowers, and all that. So if it gets very, very loud, I apologize. There's not much I can do about the hordes of gardeners who are out there making a whole lot of noise. But otherwise, welcome to this session. Tiger Pleb is waving. Hello, Tiger Pleb. I love your avatar. That's so cute. Great to have you here with us. So if you haven't come across me before, I'm Jim Bennett. I'm a cloud advocate of Microsoft, IoT nut, and general all-round geek. And you can find me all over the internet at Jim Bob Bennett. Twitter, GitHub, Instagram, LinkedIn. Please feel free to connect. If you've got any questions about what we're covering today or in any of my other sessions, please get in touch. I'm here to help you. Now, today's session, we are focusing on, your PowerPoint's working, focusing on IoT for beginners. This is the third in our 4-part series on digital agriculture. So if you haven't caught the first 2 episodes, we will drop a link to the videos for that in the chat. We've got a YouTube playlist with the last 2 episodes, then one today and one next week. Oh, brilliant. Thank you very much. Yep, the link there is in the chat. Now, so today we're focusing on part of our IoT for Beginners curricula. But one thing I will say, and I say this for all my streams, these streams can be a conversation. This is not just me talking at you. This is your chance to get involved, ask questions, get involved in the discussion, bring your knowledge. We had some folks last week, for example, someone who is actually farming and looking to bring digital agriculture into their farming. So we want to hear from you. We want to learn from you just as much as I want to share some cool information with you. So while I'm kicking off all this intro, how about you all jump in the chat and let me know if you came to our previous two sessions on this, and if not, where in the world you are. So we know from the last couple of episodes, we've had a whole contingent from Scandinavia, a lot of folks across the Americas, some folks from India. So please let me know where in the world you are if you haven't joined us before. And if you have joined us before, say hello. It'd be great to kind of just chat to you all. So today we're focusing on IoT for Beginners, which you can find IoT for Beginners at aka.ms/IoT-beginners. IoT for Beginners is our free, open source, MIT licensed 24-lesson IoT curriculum. You follow that link, it brings you here. It's all on GitHub. Oh, Adrian's back from London. Hey, Adrian, glad to have you with us again. Awesome. Yeah, I believe you're here for the last 2. So thanks, Adrian. Glad to have you back. And Abdul Vase, hello from India. Awesome. Welcome. I know it's quite late in India, so I appreciate you joining. Cool. So we got some Europe. We got some India. Where else are we from? Let me know. So IoT for Beginners says a 24-lesson IoT curricula designed to teach you IoT from the basics. So we have 24 lessons that take you on a journey from farm to table. We start with a little bit about what IoT is. Then we look at digital agriculture. We look at logistics, manufacturing, retail, and consumer IoT. And each step of the way, we teach you some IoT concepts, and then you build hands-on projects for each section that actually cements those ideas. So you learn the concepts and then you build the projects. And this is all here. So 24 lessons. We have got video content. We've got quizzes. Let's just pick a lesson here, for example. Yeah, we've got video content, we've got quizzes, check-ins all the way through, all the information you need, and then there's assignments right at the end, pre and post quizzes, some suggestions on review and self-study, and a whole lot of great content for you to learn about the Internet of Things. And to say, this is completely free for you to use. It's MIT licensed. So if you want to use this in a classroom or for your own personal study or in a study group, whatever, you can. And you can just slice and dice it and just rip out the bits you want. You want to just teach digital agriculture in the classroom. Just take this, format it in the way you want, and teach it in your classroom. Tiger Pleb says, I'm from Web World and come to the IoT sessions. Ah, yes, from somewhere out on the web. Awesome. Glad to have you with us. And Aurelian Bonham-Bell is from Cameroon. Oh, nice. So some Africa this time. Awesome. Awesome. Glad to have you here. Cool. So with IoT for Beginners, obviously we are focusing on the digital agriculture section at the moment. So we are focusing on some of these lessons here in the middle where we look at digital agriculture. We've actually run the first 4 lessons, the introduction to IoT, in the past, and we have a whole playlist of these lessons. We have the 4 lessons, plus we have office hours where we kind of dive more into discussion, all available on Reactor YouTube. We'll get a link to this dropped in the chat. In fact, I'll just put the link up on the screen. That's the link there, IoT-beginners-videos. We'll get that dropped in the chat, but that's how you can access all of the videos of the first lesson. Now, when it comes to doing IoT, the T in IoT stands for things, and that means hardware. So traditionally with IoT, you would buy hardware and use hardware to build your solution. Okay. Now, we have worked with our friends at Seed Studios to actually make these kits a kind of a one-click purchase. So all the hardware you need to build all the projects inside IoT for Beginners, you can buy from Seed Studios. Just the link's been dropped to the chat. Thank you very much. But it's just one click and you can buy the hardware. Obviously, supply chain constraints are there. You may not be able to get a Raspberry Pi with it if there's none available. But you can buy the hardware prepackaged if you want to. Now, if you don't want to spend any money on hardware, you can do everything in the entire project using virtual hardware. So we built this thing called Counterfeit. This simulates hardware. You code this as if you were coding a Raspberry Pi, but instead of using physical hardware, you launch a web app and define the hardware in that and say, I want an LED and a sensor and an actuator and a relay and all that kind of stuff. So you can do everything without spending any money at all if you don't want to buy any real hardware. So that's kind of the introduction to IoT for Beginners, if you haven't come across it before. But today we're focusing on migrating our plant to the cloud. So if you joined me over the last couple of weeks, we've been working on our automated soil watering system. So here's our hardware. We have a Raspberry Pi with a Grove base hat. So this is from Seed Studios. It's a way to just do very easy plug and play for hardware. So you don't have to worry about breadboards, resistors. You just plug the cable in and use the libraries to control the hardware. We've got soil moisture sensor sitting here in our soil, capacitive soil moisture sensor. We talked about that in the first episode. We talked about how sensors can connect to IoT devices and how you can calibrate sensors and what the data means. Then last week, we added this relay, which is connected to a pump. And we set up kind of a whole feedback loop. So depending on the soil moisture level, the relay clicks on or off, sets the pump going, and pumps water around. And luckily, I didn't flood my desk and I didn't electrocute myself because, water and electricity don't mix. And then we connected everything up via MQTT, just using a public free MQTT broker, and built a little bit of server code to control the relay turning on and off. So that's kind of where we got to last week. One thing I did make the point that we were using a public MQTT broker just to illustrate the whole connectivity idea and kind of talk about how you'd manage potentially multiple actuators using sensor data from multiple sensors with some kind of core server that does your logic, that looks at all the sensor data and makes decisions. Now, it's a public MQTT broker. It is not secure. The old joke that the S in IoT stands for security. There is no S in IoT. So that's obviously not what you want to do for a production deployment. So today, what we're going to do, we're actually going to look at migrating this to Azure IoT Hub. So we're going to look at the cloud. We're going to look at how we can take advantage of cloud IoT services to make this more secure, more stable, more reliable. So that's the purpose for today. So Here's a question for you all. Have you come across the cloud before? Let me know in the chat, yes or no, if you've come across the cloud, and have you done any IoT with the cloud? So I'd love to kind of hear what your experiences are with the cloud and doing IoT with various cloud services. Doesn't matter which cloud service, we're all friends here. Tiger Pleb says yes, awesome. Yep, doesn't matter which cloud you've used, we're all friends here. So if you've done it with Azure, with any of the other clouds around, then please let me know. If you've done it with GCP IoT Core, then I kind of feel for you. I've heard they're deprecating that service, so you've got a year to migrate somewhere else. So maybe if we show you how Azure works, this could be a good solution if you need to migrate from GCP IoT Core before it gets deprecated next August. Cool. Tiger Club says, I use Bluetooth though. Does that count? Yeah, yes. We touched on this a little bit last week as one of the connectivity mechanisms. A lot of IoT devices do connect over Bluetooth. So if you've got like a Fitbit, the various wrist-mounted activity trackers, they do not connect to the cloud directly. A lot of these connect via Bluetooth to a phone and then use that as like a hub to connect to the cloud. And you do get other IoT devices like that, and they will connect over Bluetooth to some form of central hub and connect to the cloud. So yes, that very much does count. I've got one of those Ecobee smart thermostat thingies, and that has got multiple sensors around my house, and those sensors connect over Bluetooth to the Ecobee hub, and that acts as a central hub that connects the cloud. So this idea of having sensors using some form of wireless protocol to connect to a gateway device is fairly normal in IoT. So yes, Tiger Pleb, that definitely does count. Awesome. Cool. So for those who haven't come across the cloud, well, let's just take a few minutes to talk about what is the cloud. If you come across this should kind of be some good revision for you. But let's just take a moment to talk about what is the cloud. Now, historically, going back in time, we used to have on-premise data centers. So the idea was, if you needed to have servers to do stuff, you would buy and maintain that. So you would buy a lot of servers and you would manage that hardware yourself. A lot of companies still do this now. So they will have either anything from like a basement in their office to a whole big building where they manage their data centers. They have a whole lot of servers and the companies do everything themselves. So they will buy hardware, maintain the hardware, manage power and cooling, networking, security, software management, the lot. Everything's handled in-house. So you need servers. You'd have purchasing teams that would go and buy the hardware and then manage the maintenance contracts on that hardware. You would have power management and cooling teams. So you would work out how much power you need, how much air conditioning you need in the building. You obviously have to manage networking, network isolation, network cabling, just connection to the internet. You have to manage security, whether it's security on your security of digital access, so managing logins to the hardware, or physical security of the building. And then you have to manage all the software. You're deploying operating system patches, rolling out hardware, things like that. And that was how it used to be. Each company would do this themselves. And this led to not the most optimum setups. So, for example, a friend of mine, when I used to live in Hong Kong a number of years ago, and a friend of mine there, he was trying to get a new Linux server made available to his team. And he was working for one of the largest investment banks in the world. It took him 6 months to get a Linux server because he had to go to the various procurement teams, get various quotes, make a decision on the hardware he wanted, then send that to an allocation team that would work out when they have a slot in the cloud, not the cloud, a slot in their racks in the data center, when they could allocate power and cooling, because each server generates heat, needs a certain amount of power. Then they had to work about the networking, install security patches, install the operating system. So from him saying, I need a server, to him having the login and could log in was 6 months. And that's because these data centers are usually running pretty much at capacity. There's no point in buying extra that they don't need. And Keita Tamar says, didn't join the last 2 sessions, but came across the list today and joined. And Keita from India, someone else from India. Awesome, welcome. If you don't want to catch up the last 2 sessions, we'll drop a link in the chat to the videos from the last 2. Hopefully there should be nothing that you really need to worry about for, thank you. There's the link, there's the YouTube playlist. There shouldn't be anything really that you need to worry about today. We're focusing on the cloud and getting connected to the cloud. So most of what we talked about last week, probably not that necessarily relevant here. Just understand that we've got a soil moisture sensor and we're connecting it to the cloud. But yeah, Ankita, glad to have you here with us. Thank you for joining us. So as on-premise data centers, it's, yes, you get to manage everything yourself. Yes, you get data sovereignty in that the data lives in your building and your building only, but there's a lot of management you have to do. And certainly for small companies, you may end up with one person doing everything who's not an expert. Now, the idea of the cloud is, as some people joke, it's somebody else's computer. Really, it's somebody else's data center. And the idea is, instead of you building and managing a data center yourself, you outsource your data center to a provider. So somebody in a large company will build a huge data center. So they have the economies of scale. They will manage buying the hardware, making sure you've got extra hardware in place, the power, the cooling, the networking, the physical security, digital, the whole thing. And then you just rent the computers that you want. So somebody else does the hard work, you just rent it. So you can just go to them and say, I want another computer. And because they've already got capacity in place, instead of waiting like the 6 months like my friend Mike did, you can have a computer in 30 seconds. Just click a button, this spins up a new computer. And then you rent it. So you pay per second, per minute, per month, kind of whatever payment model you've chosen. And this is great because if you have spikes in your need, you only pay when you need it. If you're like a fast food delivery service, for example, and like in America, Super Bowl Sunday is really big for food delivery. So you're going to be right up here. Weekends, you might be right up here. During the week, a wet Tuesday afternoon, you might be right down here. You don't need to pay for all that extra compute power. So with the cloud, you can kind of scale up and down. Just rent what you need. I'll rent more computers on a busy time and then less when it's quieter. But the cloud also introduced what's called platform as a service and software as a service. So rather than renting computers and managing software yourself, you can essentially rent the software. So rather than saying, I'm going to rent 10 computers, well, think back to our data center, rather than buying 10 computers and putting a database on there, the cloud means you can just rent a database. You don't care about the computers it's run on, someone else's problem, you just rent the database and then say how much scale you want. So it kind of just allows you to outsource a lot of this management for everything. Now, to kind of give you an idea of the scale of the cloud, this is a photograph taken a number of years ago from one of the Microsoft data centers in Europe. So it's a little bit of a blurry picture where I've blown it up quite large, but you might be able to make out these little blobs here. These are cars. So you think just how big this data center is here. You look at the size of these cars. This is all computers. So literally a multi-trillion-dollar company like Microsoft can afford to buy a huge area of land and build a massive data center, and then you rent computers on that. Now, this is an old picture. This was the first version of it. They then expanded. Now, this picture was taken before they finished the expansion, but this was the proposed expansion area, which is 5 square kilometers. So you imagine this bit of the back here, this is what we saw in the previous picture. This bit of the back here is what we saw in the previous picture. This new area here is 5 square kilometers that they're building. And this was taken a number of years ago. So think just how big these data centers are. These are big enough that companies like Microsoft need to actually talk to the government about the amount of power that's being used. This actually affects national infrastructure because they pull so much power. But a lot of times they allow things like companies like Microsoft to provide the power, which means we can build green power stations. So we can kind of think about being carbon neutral, carbon negative, and think about being water neutral, water negative, all these different things, and actually build those on a big scale. So we can build a massive data center, and then we can build a green energy station right next to it. As Tiger Pleb says, tree! Yes. Load of trees around there. Shame some of them have to be cut down for a data center, but yes, a lot of trees there. But as companies like Microsoft are actually looking to be very efficient with these, looking to be things like carbon negative. Even recently, we stuck a data center in a big round, essentially a submarine, and stuck it underwater to see whether that would work for cooling. But it kind of allows us to, with the economies of scale, to look at things like green energy. And then once this is all filled up with computers, they're not all going to be in use. And so there's plenty that aren't being used. So when you as a customer need to expand, give me another computer, got another computer. So it kind of allows you to do a lot of things that you can't do on-premise yourself without a load more work. You can take advantage of the economies of scale of a company like Microsoft. You can take advantage of the fact that Microsoft spends billions on security every year, rather than relying on one person who manages your networking and security and purchasing and everything if you're a small company. So it kind of gives you a lot more power. Now, today we're focusing on Microsoft Azure, which is the developer cloud from Microsoft. Obviously, Microsoft Reactor, I work for Microsoft, Microsoft Stream. We are talking about Microsoft Azure today, which is the Microsoft cloud. And particularly, we're focusing on the IoT services. So we're not really going to dive any deeper into what Azure offers. We're just, in terms in general, we're just going to focus on the IoT side. And Fuel Snable is in the house. Hello, Fuel Snable. Great to have you here. Fuel Snable pops up on quite a few of my streams. So the one more from the Scandinavian contingent. Glad to have you with us. Awesome. Yay. Yay, Fuel Snable's back. Woohoo. Cool. No, glad to have you here. So Fuel Snable's going to enjoy this because we can touch on IoT security. And Fuel Snable likes to joke about IoT, about the lack of security. So this is going to be fun. And Code with Sean says, howdy. Hello, Code with Sean. Glad to have you with us. Cool. Cool. Seeing the few of you on Twitch are the ones joining in here. So hello to the Microsoft Developer Twitch channel. Glad to have you all with us. Fuel Snable says, I created a Reactor-inspired shader you can put in your Windows terminal. I think it looks pretty sweet. Oh, nice. Nice. Yes, yes. Can you send me the link? Either drop it in the chat here or send it to me, Jim Bennett, on whatever your favorite platform. My colleague Sam in San Francisco is big on shaders, so they would love this. And yeah, I'm more of a Mac person, as you may know, but I'm going to be dabbling on Windows next week. So yeah, I should set that up. So yes, please get in touch. Send me a link. Kobe Sean says, I met you at KCDC a few years ago. Awesome. Sorry, I don't recognize you based off your avatar. And I must confess, I met quite a lot of people at KCDC. But no, welcome. Glad to have you here. KCDC is the Kansas City Developer Conference, which is not in Kansas. It's in Missouri, because Kansas City is in Kansas and Missouri. There's two. I'm not sure if there's two Kansas cities or one city cut in half. There's a great developer conference that I was at just over 3 years ago. So funny story, working for Microsoft in the UK, working on relocating to the US. And it was we got the visa sorted, waiting for the relocation. I flew from UK to KCDC. And whilst I was at KCDC, we got the confirmation of, yes, the move is happening right now. So literally my wife had to manage everything because I was in KCDC and then flew back from KCDC to the UK for about 3 days before flying back to the US to move here. So it was a great conference. It was a really, really good conference. A couple of days, good conference. Then I had a kids conference on the Saturday where I did some Minecraft sessions and a few other sessions. So yeah, really cool conference, KCDC. Kobe Sean says, oh, wow. Yeah, it was a pretty manic time, Did you see my shoes? I have to ask, did you see my shoes? Because I was wearing some very cool shoes during KCDC, which if you saw them, you would remember them. So yeah, if you ever get a chance to go to KCDC, really, really good tech conference. Highly recommend it. Cool. So we're talking about Azure. Kobe Sean says, I'm sure I did. It was the Microsoft booth. Yes, I was wearing the light up shoes. I don't know if you remember I had white shoes with LEDs in them, so they actually lit up. So I had them glowing bright blue. So yes, if you saw the bright blue lit up shoes, that was me. Yeah, good conference. A lot of fun hanging out at the Microsoft booth. Cool. So we're talking about Azure, talking about IoT. Now, the first step of getting started with the cloud. Kobe Sean says, yep, I did. Yeah. So I always just do every conference with my light up shoes. In fact, you know what? As a side tangent, I'm not sure if they're charged, but don't know how well you can see this. Let's try. And as you can see, they light up. So those are the shoes I was wearing at KCDC. I know it's not probably a bit hard to see because it's not the darkest in here. But my conference shoes, not really worn them because of the pandemic. So I haven't really had a chance to wear those. But those are my conference shoes, my light up conference shoes. They're not IoT enabled. At some point, I need to work out how to wire some kind of Bluetooth controller in there so I can IoT them up a little bit. But I haven't had a chance to do that yet. Cool. Okay, so we're talking about the cloud, and obviously the first step of the cloud is you need to sign up with a cloud account. So the cloud is there for you to use. You sign up with an account, and then you have access to all the cloud services. And Azure has a free account that you can use. So go to azure.microsoft.com/free. That will give you access to a free account. You sign up. You do have to give a credit card. That is to validate that you are a person, not a bot. We don't want people setting up Bitcoin miners and things like that. So you have to verify you're a person. You get $200 of free credit to use in the first 30 days, and then 12 months of free services that you can use, and then a load of other services are free for life. So you need a credit card just to verify you're a human. We do not bill your credit card unless you decide you want to migrate to a pay-as-you-go account. If you're a student, azure.microsoft.com/free/students, you need to validate with a student email address, so a .edu, .ac.uk, .ac.jp, whatever, an actual academic institution email address, and then you get $100 worth of credit that lasts a year, and then 12 months worth of some services for free, and that renews every year you're a student. So sign up here, and that gets you signed up so you get going with Azure. So once you're signed up, obviously we're here for IoT. You want to spin up some form of cloud IoT service. So this is kind of one advantage of using a public cloud, is that the public cloud provider can build an IoT service that you can then use. So it's not like you are renting a server, installing an MQTT broker yourself, and managing that yourself. Instead, there's a whole IoT service that's built and available for you to use. So it's managed by the cloud provider. They manage security, reliability, scaling, and maintenance. They do the whole thing, and you can just connect to that and said from your IoT device. A lot of them use kind of lightweight messaging protocols like MQTT, AMQP, whether they're an actual MQTT broker or they have an MQTT-like interface to the service, but you can connect using these kind of lightweight messaging protocols. So they're very much designed for IoT. And so you don't have to worry about managing it. If you've got 2 IoT devices, then you'll use hardly any power. That's fine. If you then go live with a big IoT deployment of 1 million devices, then the cloud can scale that for you. 10 million devices, 1 billion devices, you can scale that in the cloud. It's literally, you drag a slider to say, I want more power. And so the cloud manages all that for you. And then all you do is you pay per month. And that's based on how much you use. The more you use, the more you pay. But there is a free tier for developers. So you kind of get going for free. And so what we're going to be focusing on today is Azure IoT Hub, which is a basic IoT service. It's a big fat pipe you connect to. You can send your messages to it and pull them off the other side. Pretty much the same as we saw with the MQTT broker over the last couple of weeks, but we'll be doing it over Azure IoT Hub. You can also get IoT SaaS platforms. So you can have the basic service, which is your data pipe, or you can have a full SaaS platform where you get reporting and charts and graphs and all that kind of stuff. In the Microsoft world, we think called IoT Central, and that's a whole software as a service platform for provisioning devices, for creating dashboards to monitor your data, for reporting, alerts, data export, a whole kind of thing. It's a whole software as a service platform you can get, IoT Central. So we're not touching on that. We're just going to focus on IoT Hub. And so the way that cloud IoT services like IoT Hub work is you have your IoT device. You would then connect to the IoT service. You can either use something like MQTT or HTTP, or you can connect using an SDK. May sound a bit odd thinking about using HTTP, making web requests for an IoT device to connect to an IoT service, but the reason for that is usually based around firewalls. So if you've got some kind of legacy network set up where you cannot open up the firewall to get an MQTT message through, you can usually send an HTTP message. So you can connect. So a lot of these IoT services you connect with MQTT, HTTP, MQP, or you would use an SDK. So you actually use some code for your device to connect. And then you would connect to the IoT service, and the IoT service acts as some kind of message broker. So you send messages from the device, and then you can have other parts of your IoT application connect to the IoT service and then pull those messages off. And that can either be by an SDK or something built into the cloud. So think about Azure IoT Hub, for example. I can use an Azure IoT Hub device SDK to send a message from my IoT device. This is what we're going to do in a minute. That message goes to my IoT service. And then I can then pull that message off my IoT service using some of the built-in event processing. So I can literally have my IoT service send that message onto some code to do something with it. And that's what we'll look at next week, is they're doing something with on the code side. So this week, we're going to focus on getting our IoT device connected to the IoT service. Next week, we'll take data from the IoT service, our telemetry message, send that to cloud and do stuff with it. Now, the S in IoT stands for security. Phil Snable will probably make some IoT security comments. I know that's a popular topic for them. But yes, you need to think about security with IoT. The S in IoT stands for security, the old joke, but you've got to think about IoT security. It's literally just go on the internet and Google with Bing for IoT security horror stories and IoT hacks, and you will be scared. There are so many hacks, whether it's hacking a casino via a fish tank or accessing cameras in people's houses. There's so many hacks out there. Some of them are very scary. I mean, I'm an IoT nut, absolute IoT nut, but there's certain IoT devices I will not use because there's too many horror stories. So security is fundamentally important to everything you do. And the big advantage of using a cloud IoT service is they provide the enterprise level security for you. You don't have to worry about securing your MQTT broker. You can rely on the cloud. And these clouds, they spend billions on security. So as long as you follow their best practices, you are as secure as you can be. Nothing's ever perfect, but you are as secure as you can be. So, for example, when your device connects, only permitted devices can connect to your IoT service. And that can be done using either a key or a X509 certificate. And so in an ideal world, you would have some kind of trusted module on your device that contains the key in an encrypted, inaccessible format that only your device can access. And then the device uses that to connect to your IoT service. The wrong key, you get blocked. You don't get access. Only the right key gives you access. And then on top of that, you can actually add services that monitor for unexpected behaviors. So if you use Windows, for example, and you use Microsoft Defender as your antivirus, you can get Microsoft Defender for IoT. It's not a big antivirus, essentially, but it's a little bit of code you can put on your IoT device and code that runs in the cloud to allow you to monitor for firmware changes, for rogue data, anything that seems out of the ordinary. If you've got an IoT device that sends a temperature packet every hour, and then suddenly it's sending weird requests every few seconds, Defender can detect that and block that. Fuel Snubber says, I wrote a small description on how to install the shader. Oh, yes, this is the Windows Terminal shader. Yes, yeah, I'm really excited about this, so I want to see this. So yes, please share the link, because having a reactor shader for Windows Terminals can be very, very cool. Did I get the link? It's not in the chat, so I don't know whether if you put the link in the chat, or did it star it out? Oh yeah, so if I'm seeing I'm seeing stars in the chat. I think it's the link is being converted to stars because you're not allowed to post links. It's kind of just basic. It's the moderation we've got that blocks people posting links. Can you? I mean, I'm Jim Bob Bennett on all the platforms. Twitter, LinkedIn, and all that. So send it to me directly. And then if we can we can check it out. We can share it next week with everyone. Code with Sam says links not allowed in chat. And Ron, an engineer, says I think Twitch blocks that stuff. Yes, so the stuff does get blocked. We can post links, so you'll see whenever Microsoft Reactor posts a link or Microsoft Developer posts a link, we can do that because we own the chat. But Twitch blocks a lot of that, gets starred out. Send it to me directly, and then I will share it with everyone next week. That's so cool. I love it. So just think about security. Even Twitch has security because you could be sharing dodgy links to Bitcoin miners or hackers or other such things. So security, very important. Cool. So let's actually create an IoT service. So what we're going to do is we're going to create an Azure IoT Hub that we can then connect our device to. Good note put in the chat. Also sent to reactor@microsoft.com. And it'll be sent my way. So yeah, cool. Yeah, we'll check it out and share that next week. That's so cool. Okay, so demo time. Let's actually create a resource group and an IoT hub. That's what we're doing now. And this is all documented inside IoT for Beginners. So once again, I'm going to be kind of copying and pasting from IoT for Beginners to show that it's all here, and then using this to actually put something together. So the first thing is where I do everything. So I'm going to do everything using the command line. Now we have an Azure CLI, which is an Azure command line that you can use on all different platforms to create things in Azure. There's multiple ways to create services. I'm going to do it via the command line. Now, with this command line, the first thing I'm doing is, once you've got the command line installed, you need to install the Azure IoT extension. Now, one place I can use the command line is actually from the Azure portal itself. So Azure has a UI I can use to create services. And in this, they have a thing called a Cloud Shell. And this is a command line that I can use that's already connected and authenticated as me. So I can go in here and actually run commands inside here. Now, the first thing I need to do is actually install an extension for Azure IoT. Now, so the Azure command line does a lot of generic things across Azure, but where there's so many different services, the idea is you bring in extensions to add capabilities. So we have an Azure IoT extension that gives me capabilities. Now, the reason I'm doing this in the Cloud Shell, I could do this on my Mac. If those of you who've been on my streams before know I am a Mac user. However, there is an issue with the Azure IoT extension on Apple Silicon. When it connects to handle messages, it uses an underlying library that is not supported on Apple Silicon. So if you use Apple Silicon, you cannot use the Azure IoT extension for certain things. You can create IoT hubs, things like that, but you cannot get messages off an IoT hub on Apple Silicon. So I'm doing everything in the Cloud Shell. Issues have been raised. The team is looking on the best way to do it. But yes, our Apple Silicon support is not the best. So once I'm logged in, so because I'm in the Cloud Shell, I am logged in to my account on Azure, and I can actually list my accounts. And this will actually give me a list of the different subscriptions. So when you're in Azure, you can have multiple subscriptions. So you might have, for example, a developer subscription, a production subscription. Or if it's your personal account, I mean, I'm using Azure for Students one, for example, but I could have multiple subscriptions in here, multiple different accounts. So that's me all set up. I've got my subscription. So the first thing I want to do is create what's called a resource group. So the way Azure works is every time you create anything, a service, database, virtual machine, whatever, it's called a resource, and you have to create it inside a resource group. And these are simply logical groupings of resources. All the resource group means everything that you create lives in this one resource group, and then you then have the power to manage that resource group as a whole. So you can delete a resource group, and that will delete every single resource in there. So it's kind of a great way for grouping up projects. Obviously, how you group resources together is entirely up to you. You could have one resource group for an entire application. You could have one resource group for one part of application, different from another part. It's kind of up to you. For what we're doing here, we're going to create one resource group to put everything in, so that when we're done with our project, we can just delete that resource group to get everything to be deleted. Now, Kobe Sean says, I find it strange a resource group has a location. It makes no difference. Yes. So we have this idea of locations. So we have these data centers all around the world. This is our list here of all our data centers all around the world. And so we have East US, South Central US, West US, Asia Pacific, Europe, Canada, France, Germany, India, South Africa, Switzerland. Yeah, a lot of these all around the world. And when you create a resource group, let's create the resource group now. I'm going to create one. I'm going to call it soil moisture sensor, and I need to give it a location. I'm going to put this in West US too. Now, resource groups, because they're virtual, they're just logical groupings. You have to give them a location, even though they don't. You can put resources in that resource group from multiple locations. It gets a little bit confusing here. So every resource you create needs a location. You need to say which region, essentially which data center you want to create it in. But with the resource group, you have to say which data center you want to create the resource group in, even though the resource group is a logical grouping. But yes, So I'm just going to create one here called soil moisture sensor in West US. And this is just my bucket to put things in. Now, the location thing is important. You have to think about where in the world your data is coming from or where is it going to. So if I've got an IoT device in the Northwest of the US, it makes no sense for me to send that data to New Zealand. But if I'm collecting data in New Zealand, I would send that to New Zealand. But I wouldn't, if I'm collecting data in Australia, I may not send that to New Zealand. I may want to keep that in Australia. So you want to pick a location that makes sense of where your data is, as close as possible to your data. Also, think about data sovereignty. Different countries have different laws around where data can live. So if you're gathering things like medical data, that may have to stay in the country that you're in. So if you're doing an IoT deployment in Germany, for example, you may have to put that in a German data center for data sovereignty rules. Fuel Snail says the metadata for the resource group needs to be stored somewhere, perhaps a location. I mean, yes, somewhere we have to have the metadata that's stored. It's just, it's a global thing. It's accessible from everywhere. We have a global location. Maybe there's things that could be improved around resource groups, such as when you create a resource in a resource group, if you don't specify the location, it defaults to where the resource group is. So Tiger Pleb says, how big is the difference between these locations? Sometimes my location choice not available. Right, great question. I mean, obviously, there's a difference in time of flight. So the difference in how long the data takes to get from somewhere to another. So if you need an instant response, you don't want to be sending data halfway around the world. That's still a few milliseconds to get data halfway around the world. So there's a difference in terms of how fast you access the data. Difference in terms of data sovereignty. If legally you have to keep the data in a certain country, then you have to keep it in that country. If you are legally required to keep medical data in, just pick a country at random, in Luxembourg, for example, then you wouldn't be able to use a cloud that didn't exist in Luxembourg. I don't think we do have one in Luxembourg. So there's certain requirements around data sovereignty that you have to use. And also we have had limitations in terms of availability of software and services. So as we build a new region, a new data center, we don't necessarily have all the software, all the services available. Or recently we've had limitations based off supply chain. We haven't been able to spin up GPUs in certain data centers because we physically cannot buy enough hardware because of supply chain issues. So there is kind of a whole lot of different differences. But the biggest one is time of flight of data and data sovereignty. Does it need to live somewhere? Furious Tiger asks, why am I using the CLI versus the GUI? Any specific advantages? Not really. I'm a GUI person. So I would normally do everything for the GUI. The reason for using the CLI in IoT for beginners is because this doesn't really change, whereas the UI does change. And so if I put screenshots in here with the UI, then I'll have to constantly update those screenshots, and then I might have to localize it. IoT for beginners is being translated into multiple languages by the community, and so it's easier to translate the text and leave the commands the same because these are usually in one language, or maybe change the output in text than it is to change the images. So we chose the CLI because it's just easier for creating the documentation. Otherwise, no real use. I normally do stuff for the GUI. Fuel Snail says, I've been wanting to buy a new GPU for years. Yeah, they got stupidly expensive. They're getting cheaper now, but they got stupidly expensive. So we certainly had issues. We had to limit some of our availability of GPU VMs for data science because we just couldn't get the hardware. So cool. Right. So we've got our location. We've created our group. Let's create a resource group. Now let's actually create our IoT hub inside a resource group. So this is my command here. AZ IoT hub create. Give it my resource group, soil moisture sensor, the one we just created. We're using the F1 SKU, which is free. 8,000 messages a day we can send for free. So this will not cost us anything to create this IoT hub, which is cool. We need to give it a partition count, which is how many things inside to manage our data. 2 is the minimum. That's fine. Then we need to give it a name. Now, this name becomes part of a URI for this. So you will need to have a globally unique name. So if I call this soil moisture sensor, someone may already have grabbed that name. So I'm just going to put GIMB on the end to make it a unique name. But this needs to be globally unique across all IoT hubs because this forms part of the URI. So run this will go off and create it. Say it's free, 8,000 messages a day, will not cost me anything. And it's blocked 8,000 messages a day. So the 8,000 first message just gets lost, which is good because I don't want to spend 8,001 messages and start getting charged. It doesn't do that. It just blocks it at 8,000 messages a day. So that's going to go off and spin up our IoT hub. So while that's running, let's talk about how we communicate with an IoT hub. So rather than relying on you defining your own topics, we talked about this a little bit with MQTT before, where you define your own topics to publish and subscribe to. IoT Hub kind of does a lot of that kind of stuff for you, and it actually divides communication into 4 things. First of all, you have device to cloud messages. So this is telemetry. So this is messages from your device. This is where your device sends your soil moisture data. So it goes from the device to the cloud. Usually a JSON blob, can be binary data, whatever, but that's device to the cloud. And when it gets received by the IoT service will then add extra details to that. So it'll add things like the device ID, the time it was received, things like that. So it kind of enriches it with data specific to the device. And that way, if you think, when we talk about MQTT, you could subscribe to just certain devices. You could do that by filtering the messages based off the device ID that gets enriched into the message. So device to cloud message. You then have cloud to device message. Yep, good spot. Good spot, Tiger Pleb. Good. I'm going to fix that. I put that there to make sure people were paying attention. That really wasn't a mistake by me. No, great spot, Tiger Pleb. So number 2 is cloud to device, C2D. Yeah, thank you for pointing out my spelling mistake. So that's where you can just send a general message to a device. This might be some kind of heartbeat status message, just something where you want to send it to the device where you're maybe not too worried about receiving it. It could be a message telling the device to, giving it some kind of information that's relevant. Now, the more important messages that come from the cloud to the device are what's called direct method requests. And this is a message the cloud sends the device to instruct it to do something. And it wants a response. So when the cloud says to the device, update your firmware, turn your heating system on, turn on the pump, that is a request to the device to do something, and it requires a response. And if the cloud does not get a response and say, I've done this, the cloud knows about this. And so my application can send a direct method request to the device. And then the device, if I don't get a response to the device, my application knows. So it's kind of very much that kind of response system for sending a command to the device to do something. And then you have device twins, which is essentially a JSON document that is kept synchronized between device and cloud. If I update it on the cloud, when my device connects, it'll download the latest version. If my device is offline, when it reconnects, it downloads the latest version. The device then update that and then send that to the cloud. If the device is offline, it will send it when it is connected. So kind of useful for keeping state data synchronized between device and cloud, and it's kind of persisted, which means if I have a device and my device breaks, I can replace that with a brand new device with the same device ID, and that would pull down the same device twin. So it's kind of great for configuration. Yeah, if I'm configuring a door control mechanism for my door, which has got a particular device ID, if that breaks, I can then get new hardware, give it the same device ID, and it will download the device twin and know how to configure my door control system. So it kind of allows you to have this shared configuration that's maintained by the cloud. So that's the different methods of communication. When we think about telemetry, our soil moisture sensor, that's a device to cloud message. And then we think about turning our relay on and off, that would be a direct method request. So let's do that. Let's actually connect with that up now and get data zipping around, because it should be, yep, it's completed. Our IoT Hub is now there. In fact, if I go to the GUI, the question was asked about the GUI. If I go here to the GUI, I look at my resource groups, you will see I've got soil moisture sensor resource group with my soil moisture sensor Jimby IoT Hub. So that's there, that's created. Cool, so before a device can connect, I have to register my device. Yeah, this is talking about security. Only known devices can connect. So drop the command in here. give it my hub name, which is Center. So I'm saying create me device identity. Create me a device. I want my device to be called soil moisture sensor, very generic name, in my IoT Hub. And that will tell IoT Hub that we need a device. In fact, if I now look here, if I go to my devices in my UI, you'll see I have a device. And this device, if I go and bring it up here to look at, we have a key. We have a secret key. So this device is connected using a key rather than a certificate, but I have a key. I have a connection string I can use, which has got my soil moisture sensor jimb.azuredevices.net URI in there. But this is how I connect. Yes, I'm showing you a key over a live stream. Yes, it's bad security practice. Yes, I'll be rotating my keys when this is finished. So it's fine for what I'm demonstrating. But now I've got this. My device can only connect if it uses this key. No key, no connection. And then if I want to actually get the connection string, I can get it from the UI here, or there is a command for doing it. Same thing, show me the device. Oh, if I could spell sensor, and that's my key. Same key as I got there. I can see my key. Fuel Sniper says, it's okay, it's IoT after all. Yes, there is no S in IoT, there is no security, so let's just be insecure. Love it, love it. Cool. So now we've got our connection string, we can connect our device to the cloud. So the first thing we do, go to Visual Studio Code, where I've got IoT, IoT, IoT. Yay! We love a bit of IoT. So here I am, Visual Studio Code connected to my Raspberry Pi. First thing is I'm going to install a Python package. So I'm installing the Azure IoT Device Python package. So that allows me to, Jessica says, those chants, IoT, IoT, IoT. Yes. Tiger Pleb, my eyes. Oh. Yeah, so just install the Azure IoT Device Pip package so we can access Azure IoT over Python. So this gives us all the stuff we need to write device code in Python on our Raspberry Pi. Then once we've got that, we need to actually get rid of all our MQTT stuff. We're not doing MQTT anymore, so that can go away. Go away, MQTT. Let's get rid of all our MQTT stuff. We don't need any of that. Don't need any of that, and then we can't publish because we don't need that. What we do want to do is connect to Azure IoT Hub. So we can bring in the IoT Hub packages. Being Python, this is available as synchronous and asynchronous. There's a .aio version that uses async IO if you want to be asynchronous. We use the synchronous one here just because it's a little bit less code. That's all. I need to define my connection string. So I'm going to copy that from here. Copy button and drop my highly secure connection string in here. Yeah. As Jens West says, Fuel Enable understands the security model. 30 seconds later, the neighbor's garden sprinkler turns on. Yes, I mean, literally, if you were that way inclined and were watching this, especially when if I put this pump in water, you could turn on my pump for me because you can see this device ID. So yeah, you could potentially hack me. Send a soil moisture level of the wrong level and my pump turns on. Yes, highly insecure, but you know what? You need to see this for the purposes of illustration. And I will be rotating all these keys, don't you worry. So once I got my connection string, could, Fuel Enable says could. Don't try it, don't try it. I mean, you can try it if you want. See if you can send data. Be fun copying this key down just from the screen. One upside to a Mac, if you captured a screenshot of this, the Mac would actually analyze the text. You can just copy and paste it out. Okay, but we create our device client from our connection string, and then we connect. This gets us connected to Azure IoT Hub. Jens Worth says, let's go. I'm going to get hacked, aren't I? I'm going to get hacked. Yeah, it's all good. It's all good. So if we now run this, Python app.py, see, we're now connected. So that is now connected. Why Pi, may I ask? So Tiger Pleb asked why Pi, as in why Python? I'm using a Raspberry Pi for this, and on the Raspberry Pi, Python has got the best support for hardware. So the Grove stuff, there's Python libraries to do everything. So that's why I'm using Python. All the Grove stuff for Raspberry Pi is Python. If I'm using Arduino, it'll be C++, but for Raspberry Pi, Python is the most supported one. Genescu says, Fuel will do some pen testing as purpose of security with IoT. Yep, go on, pen test away. Why not? Try and hack me. Cool, so let's actually send some telemetry. So if I just do here, what I do here is I create a message, which is an IoT Hub message with our soil moisture, and then send that to my device client. So the SDK gives me a nice, reasonably simple way of connecting. I create my client from connection string, I connect, I send a message, and that's done. So now if I run this, that would start sending messages to my IoT Hub. So if I click on my IoT Hub here, you might see, there you go, the last hour, we're starting to get messages coming in. So it takes a while for the message to appear. Usually these charts are a few minutes out of date, but we're starting to get messages coming through as our device is connected. And then what I can do is I can actually monitor that. Let's sit back here for a second. Because the IoT Hub is basically a message broker, I can listen on the other side. So what I can do is if I just drop in a bit of code here, this is the command that does not work with the Azure CLI on Apple Silicon. So this is why I'm doing it in the Azure Cloud Shell. What this does, this monitors the event. So this will listen. Yes, update. This will listen on the IoT Hub. So acts as the message broker. And every time a message comes in from the device, it gets picked up by this particular piece of code. So you'll see 483, 485, 483, 485. So our soil moisture is going from the device to the cloud. I'm picking it up and then dumping it out to the screen just for now, just to show that it's working. Now you think about commands. So we're sending telemetry, but we want to think about the idea of this direct method requests, because last time we sent a message over MQTT to turn the relay on. Now we're going to actually add this capability to using Azure IoT Hub. And so for that, we need some kind of callback. Same as we did with MQTT, we need a callback method. We've got this method that receives a method request, and depending on the name of the method request, we turn our relay on and off. So again, it's a relatively simplistic API in that we have a method request. It's got a name field of what's being sent. We can get like other data to go with it. Put that in, and then once I've actually received my message, remember I said that you have to respond. When I send this direct method request, I need a response. I have to then respond. I have to actually say, build a response and respond, sends an HTTP status code of 200 to say, I have received this method request and I've accepted it. Otherwise, my IoT service wouldn't know whether the message has been handled or not. So I have to respond. And then I can just wire up an event, say, when I receive a method, call this method. So again, like we did with MQTT, this is my callback, same thing here. So if I now run this, this is now pumping telemetry and then listening for a direct method request. So I can go here, just going to send one from the UI for now. Where are we? Devices, soil moisture sensor, direct method request. I will call relay on. Not going to send a payload with that. Now we've got a connection timeout, so you can actually have connection timeouts. So you can send a command and say, it doesn't matter if we don't get a response now. I can wait 5 minutes or I can wait 10 minutes. So you got when you send these commands, these direct method requests, you can say a timeout. Can be as long as it responds the next day, it's fine. So invoke that. I don't know if you've heard that. If you heard that noise, you'll see from my pipes, which are not in water to avoid flooding my desk, but you've got my relay on and my pump is chugging away there. So we've received the message, direct method received, relay on. So we received that method. Same thing here. If I go and then do relay off, and there's our status of 200. Relay off, and our light's gone off, and we're no longer pumping. So that's getting that control in place. That's what we've done. We've registered our device. So we've got that device ID. So only my device can connect unless FuelSnable is going to hack me by taking my device ID. We've connected it. We've got telemetry going up to the cloud, and we monitor that to see it coming through. And then we just sent some basic commands. So that's it for today. Next week, we're going to then take the build out our cloud service. So last time we had a little bit of code running locally, connected over MQTT to listen to the telemetry and then use that to turn the relay on and off. Next week, we're actually going to move that to the cloud, take advantage of serverless code to run this in the cloud to respond to the soil moisture values and control the relay that way. If you're not signed up for next week, aka.ms/IoT-beginners-proj2 will take you to our sign up page where you can sign up to register for next week's one. But otherwise, if you're on Microsoft Twitch, come back here same time next week to join in. But otherwise, thank you very much for joining me on today's IoT for Beginners session.
Thank you all, and thank you, Jim. If you have any feedback, we'd love to hear what you have to say. I've added our survey to the screen. For this specific event, it's 16972, and as Jim mentioned, he will be back next week with his final episode. Please visit the series link on the screen or in the chat. Thank you, everyone. Until next time.
Yep, same time, same bat channel, as FuelSnable says.
Thank you. Bye, everyone.
Bye.